Video space over. Those who are online are able to see me as well.
Yes, sir.
Okay, because I have to show you some demonstration. We get started. Get started. Okay. So we'll see the next. So we get started with the 11th chapter, that is three-dimensional geometry. So this chapter is something similar to what you have learned in two-dimensional geometry. If you see, when you revisit the concept of 11th standard, you have already learned this three-dimensional geometry. So there, if you mainly concentrate on what you would have learned, it is all about the distance formula, right? You learned about different octets, and you learned the section formula and all those things, right? But this year it is going to be slightly advanced in the sense. Let's first try to understand what we did in two-dimensional geometry in our 11th standard. So in two-dimensional geometry, what is it we were concentrating upon? We were concentrating on something called as straight lines and conic sections. So what was the main objective of these chapters? So if you see the main objective of these chapters, that is straight lines and conic sections. What were you actually doing? You were mainly writing the equations of those figures, right? But the question is, when you are trying to write the equations, how many variables did you bring into consideration? Like for example, if you want to write the equation of a straight line, you wrote it as ax plus by plus c for. So here, there, how many variables were there? X and y. They were two variables. Similarly, when you wrote the equation of a circle, you wrote it as x square plus y square is equal to a square, where that is the equation of the circle with the center as the origin. Similarly, when you wrote the equation of circle, where the center is not origin, you would have written it as x square plus y square plus 2gx plus 2fy plus c is equal to 0. Right? So everywhere you see, you have only two variables. So what do those two variables actually represent? They represent that you are actually writing the equations of those shapes in a two-dimensional plane. You are writing the equations of all those figures in a two-dimensional plane. So what do I mean by two-dimensional plane? You will have only x-axis and the y-axis. But here comes a question that when I take a line, right? For example, if I take this pen to be a line, if I take this to be y-axis and this to be x-axis and this point to be the origin, if I take this line exactly in the plane of this board, I will be able to write the equation in the form ax plus by plus c is equal to 0. Okay, acceptable. But is it necessary that a line should be confined only to a two-dimensional plane? The answer is no. Right? So the line need not be confined to a two-dimensional plane, rather it can be confined to a three-dimensional space as well. Meaning, when the line was like this, you understood the fact that you need to write the equation in the form ax plus by plus c is equal to 0. But what if the same line, if it was not confined to the xy plane alone, rather it was confined in the space like this? But will you be able to write the equation of this line? Yes, you should be able to write it. But the unfortunate thing was, the tools that we have to write the equation in a two-dimensional plane is not sufficient for us to write the equation in the three-dimensional space. For that, we need to slightly concentrate on different parameters. What are they? Is what we are going to see in this chapter. But before that, we need to understand what is the logic we use to write the, or what is the tool we use to write the equation of a line in a two-dimensional plane. Okay. So when you see that, so if I have a line like this, if I have x-axis, if I have y-axis, if I have to write the equation of this line, then if I extend it in the backward direction, then we will be able to define an angle this line is making with respect to the x-axis and anti-clockwise direction. And you will take the tan of that angle, which will give you a parameter called as slope. Means for you to write the equation of a line in a two-dimensional plane, what is the important parameter that you need? You need the slope of it. What do you need? You need the slope of that particular line. But so when you have slope, what did you do? You wrote the equations in the form of slope point form, slope intercept form, right? Then you wrote it in the intercept form, normal form, different kinds of forms we took into consideration. But everywhere, the basic concept that helped us write the equation of line was. So if you see this concept, slope is related to a trigonometric function. And we know that trigonometric functions are applicable for right angle triangles. And for you to define a trigonometric value, you need an angle associated. Am I right? So, what is slope? Slope is, we would have learned it as m. But the question is, if you want to write the slope in terms of mathematical parameters, you need tangent is a function that you need. For you to define the tangent, you need to have an angle that line is making with respect to whom? With respect to the x-axis in the anti-clockwise direction. Is it right? So when this condition is not sufficient for us to write the equation of a line, when the concept is getting extended to three-dimensional space, then we are going to learn a different set of parameters called as direction cosines and direction ratios of whom? Of a line. So that is going to be the first topic that we are going to discuss in this chapter. But even before we start, is it clear that why we need direction cosines and direction ratios? It is because of the drawback that we have with respect to the slope. Slope is applicable only for 2-dimensional. Whereas if you want to write the equations of lines or any other shape, right? Lines or something called as a plane, right? Then we need parameter. If you need to write them in a 3-dimensional space, then we need the direction cosines and direction ratios of a. So here we need not break up. This is a very simple concept. If you try to visualize it, suppose I take this to be the x-axis. If I take this to be the y-axis, and if I take something towards you as the z-axis, if I take it like this, right? So I have a space. So in that space, let's say I have a line which is in this kind of an orientation. Where is it? It is somewhere randomly lying in the space. But the question is, if I extend this line in the backward direction, then I will be able to define 3 angles. What are those angles? Those are the angles made by this line with the 3 different axes. Right? So to put it very simple, if I take the line to be lying like this, you're able to visualize? If I take the line to be lying in this way, right? If I take the line to be lying in this way, then this line makes an angle with the x-axis, and it makes an angle with the y-axis, and it makes an angle with the z-axis. Z-axis is here, it makes an angle. So let's say the angle made by this line with the x-axis is alpha. The angle made by the line with the y-axis is beta. And if I say the angle made by this line with the z-axis is gamma, right? For those 3 angles, which line is being with the different axes, if you are able to define the cosine function, what is cosine? Cos function. So if you are able to define the cosine function of all these angles that the line is making with the 3 axes of the space, then those values are given a name called as direction cosines. So basically, in physics and mathematics, direction is a word which is used to define angles. Right. So if you take the cosine of those angles, we call those parameters as direction cosines. Because that is how it will be easy for us. You'll see, you'll understand the benefit of attachment focus. So as of now, I accept it as cos. We don't call it as direction sines or direction tangents. So direction cosines. Why? We'll see. Okay, so that has something to do with the vectors. Freedom. So write it down. What do you mean by direction cosines? If a line in a space is making angles alpha, beta, and gamma with respect to whom? With respect to x, y, and z axis respectively, then cos alpha, cos beta, cos gamma are said to be the direction cosine of the given line. So I hope we are able to understand. If a line in a space is making angles alpha, beta, and gamma with respect to the x-axis, y-axis, and z-axis respectively, then cos alpha, cos beta, and cos gamma are said to be the direction cosines of the given line. Here, if you see the heading, we are able to see 2 terms. One is direction cosines, and the second is something called as direction ratios. So why do we need two parameters? Let's understand that with more clarity. Okay. So when you revisit the concept of trigonometric function, right? If you look at the values a cosine function can take, the least value it can take is -1, and the maximum value it can take is +1. So whenever you are getting stuck between these two numbers, it will be difficult for us to solve problems because we need numbers greater than 1 and less than -1 as well to represent certain equations. We cannot always handle them between these values. For that, what happened is they came up with the concept of something called as direction ratios of a line. So it is very simple, right? So what are direction ratios is? If we are able to define a number, okay, I'm able to take a number, and if I say that the number is proportional to the direction cosine. So if I take a number, when I say it is proportional, means it is few multiples of that direction cosine, then those numbers which are multiples of direction cosines are what are called as direction ratios. Okay, so write down the meaning as direction ratios. Numbers proportional to the direction cosines are said to be direction ratios, or they are sometimes referred to as direction numbers also, but that is a very rarely used term. So with respect to our NCRT, we are going to use only the word direction ratios. Is that point clear? Right? So we call them as direction ratios. Now we are going to get into the mathematical details for how these are represented. So I told you the direction cosines are basically cos alpha, cos beta, and cos gamma. But every time if you start writing them in terms of cos, it becomes difficult for us to write the equation. So for that, what they have done is they have given a representation to these direction cosines. So how we do this? Cos alpha is represented with n. Cos beta is represented with n, and cos gamma is represented with n. So throughout your three-dimensional geometry, wherever you see L, M, and N, it is understood that they are trying to speak about direction cosines. Okay. Similarly, if I talk about direction ratios, the symbol used are A, B, and C. So throughout three-dimensional geometry, if you see the letters A, B, and C, it is understood that they are speaking about direction ratios. Okay. And if you see from the definition of direction ratios, that is A is just a number which is proportional to the direction. A is directly proportional to L, and B is a number which is proportional to M, and C is a number which is proportional to N. So if you remove the proportionality symbol, we can introduce a constant as A. So A can be written as AL, B can be written as AM, and C can be written as AM. So this is point clear to everyone, right? So this is the first point that we need to understand. So we can't even proceed with any other topic. Clear, right? No doubt. Now, the next topic that we are going to see is, we saw that direction cosines are represented by the symbol L, M, and N. Now the next question is, how are these three direction cosines related to each other? So how are they related? Is what we are going to see. And the answer to that is L square plus m square plus n square is equal to 1. What is it? L square plus m square plus n square means the sum of the squares of the direction cosines will give you a 1. Sum of the squares of the direction cosine will always give you a 1. So this is a very, very, very important expression to be remembered. Okay. But the question is, how did we even get this? How did we know that every time these are going to be added and they give you a 1? For that, what we will do is, see, I will explain to a 2-dimension and I'll explain the same concept to 3-dimension so that you'll be able to understand. So if I take this to be x-axis and this to be y-axis, if I take this point to be P, and if I consider the line lengths, which I call it as OP, where I take this as alpha and this as beta. I'm not taking it as 90 minus alpha because as of now, I'm seeing that this point is making an angle alpha with respect to x-axis and beta with respect to y-axis, so that I'll be able to define something called as cos alpha and cos beta. So if I take this point to be x comma y, and if I take the length of OP to be smaller, okay. So from point P, if I draw a perpendicular, then how much is this distance going to be? It will be x, and this distance will be y. Right? This height is going to be y, and this is x. Right? So from P, if I draw a perpendicular, then I'm going to get. Now, if I take this to be m and n, I'm able to see two right angle triangles, OMP and ONP. Right. So if I take the right angle triangle OMP, then the angle at O is alpha and OM is x. So what is cos alpha? Remember, OP is R. So what is cos alpha? Cos alpha will be equal to x divided by R. Correct? Similarly, if I take the triangle ONP, if this angle is going to be beta, this is y and this is going to be R. Okay. So what is cos beta? So cos beta will be equal to y divided by R. Cos beta will be equal to y divided by R. So from here I can say x is equal to R cos alpha, and from here I can conclude that y is equal to R cos beta. Okay. A small correction is not needed because we are trying to find cos square alpha which is also. So listen. If I consider cos square alpha plus cos square beta, so cos square alpha is going to be x square by r square and cos square beta will be y square divided by r square. Now tell me one thing. From the triangle OMP, if I consider this is x, then what is MP? MP is y, right? So when I apply the Pythagoras theorem to OMP, then what will I get? X square plus y square is r square.
Yes, sir.
So if cos square alpha plus cos square beta is x square plus y square, the whole divided by r square, because that is LCM. But from a right angle triangle, what can I say? From right angle triangle OMP, I conclude that x square plus y square is r square. If I substitute the value, I get r square divided by r square. So what is that you are able to understand? Cos square alpha plus cos square beta is going to be 1. Similarly, if I extend the concept to a 3-dimensional space, what will happen? So when cos alpha came out to be x by r, cos beta came out to be y by r, then what will cos gamma come out to be? It will come out as z by r, so that when you add everything, you get x square plus y square plus z square divided by r square. Sum of everything divided by r. So r square by r square will give you 1. So, but we know that cos square alpha is nothing but L square, cos alpha is L. So L square plus M square is 1, extending into 3-dimensional will give you L square plus M square plus N square as 1. Is that point clear? So this is the proof. Okay. So the reason I didn't explain it with 3-dimension is exactly like 2-dimensionals. Make a note of this. Good. Now, the next topic that we are going to see, now we understood what are direction vectors, what are direction ratios, and what is the relation between all the 3 direction vectors. What is it? L square plus M square plus N square is a 1. Now, in some questions, what they will do is they'll give you the direction ratios and they'll ask you to calculate the direction coefficients. How can we do that? So we need to start with the basic definition of the relation between. So finding direction cosines when direction ratios are given. So how do we do that? We know that L divided by A is equal to M divided by B is equal to N divided by C is a constant. Why is it so? Because A, B, C being direction ratio, those are numbers which are proportional to L. So can I say A is directly proportional to L or L is directly proportional to both B and the C? So L by A is equal to M by B is equal to N by C. I'll take it as a constant. So from this, what can I conclude? L will be equal to A times A, M will be equal to A times B, and F will be equal to A times C. Now what is L square plus M square plus N square equal to? It is equal to 1. So what is L square? It will be KA square plus KB square plus AC square will be equal to 1. So what can I do to that K? I take the K square outside. So K square into A square plus B square plus C square is equal to 1. So from this we will get K is equal K square is equal to 1 divided by A square plus B square plus C square. Or I can also say that K is equal to plus or minus 1 divided by square root of A square plus B square plus C square. So K will be equal to plus or minus 1 divided by root of A square plus B square plus C square. Now, if I take this value and substitute it in individual values of L, M, and N, I'll get L will be equal to, I'm taking this and substituting, L will be equal to plus or minus A divided by root of A square plus B square plus C square. And M will be equal to plus or minus B divided by root of A square plus B square plus C square. And N will be equal to plus or minus C divided by root of A square plus B square plus C square. Am I clear with this? So this is how the values are obtained when direction ratios are given and you're asked to find the direction. Now, the last concept that we need to know before we proceed with the first exercise is direction cosines of line passing through 2 points. Okay. So if there is a line that is passing through 2 given points, how are we going to find the direction cosines? From there, we will try to understand how to write the direction ratios as well. Okay. I repeat it, this is very, very, very important. If this is not clear, forget this chapter. That is all it is. And I'm repeating, this is one of the toughest chapters. Question to hear it right now. Constant. It's not easy like vectors. Concentrate because I've seen people getting confused or not knowing when to take direction cosines and when to take direction ratios. So you should not follow that kind of thing. So what is the heading? We need to find the direction cosines of a line. And that line is passing through 2 given points. So let the points be x1. So P I will consider it as x1, y1, z1. And Q I will consider it as x2, y2, and z2. Now what I'm going to do is, I will only find it with respect to x-axis first. Then I'll extend the concept by applying the similarity to y-axis and z-axis. So it's very simple. Observe the diagram. I've taken 2 points P and Q in a space. That is why there are 3 coordinates associated with what are the x, y, and z. So x1, y1, z1 is the coordinate of the first point, and x2, y2, z2 is the value of the point for the second point. So when I take this into consideration, now if I take a separate diagram for PQ, right, and if I extend this PQ, can I say that this line is making an angle alpha with the x-axis? So what I will do is I will extend it in such a way that I will draw wherever it is cutting the y-axis. At that point, I am just drawing a line parallel to the x-axis, so that I am saying that angle to be alpha. Correct? So what is the distance between 2 points from your 11th standard basic study? How do you find the distance between 2 points? Root of 2 minus 6. So root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Now, if I complete a triangle like this, observe this angle is alpha. Am I right? So if this is alpha, I am saying this angle is also alpha. So they are corresponding angles, right? So from P, if I drop a perpendicular onto the x-axis, then how much will this distance be? This will be x1. Similarly, from Q, if I drop a perpendicular onto the x-axis, this distance will be x2. So this distance is x1, and this distance is going to be x2. So what is going to be the distance between the respective foot of the perpendiculars? It will be x2 minus x1. So if I take this point to be n, then this is x2 minus x1. Now you guys tell me what is going to happen. What is going to be the value of cos alpha will be equal to x2 minus x1 divided by root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square.
Sir,
Yeah.
sir, I didn't understand how the angle alpha is made. Like, where is it
Because you
cut?
extend that PQ, no? You extend that PQ so that it is cutting the y-axis, and I constructed a line parallel to the x-axis. I constructed
Okay, sir, got it, sir.
parallel to the x-axis, that is alpha. So what I'm trying to do here is I'm not trying to deal all the 3 angles simultaneously. I took one of the angles into consideration. So whatever I got with respect to that, I'll extend to the other parts as well as using the concept of symmetry. So if cos alpha is equal to the difference in the corresponding what? X coordinates, then what will be the value of cos beta? Guess it. It will be y2 minus y1 divided by the same thing. So it will be y2 minus y1 divided by root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Similarly, what will be the value of cos gamma? Z2 minus Z1 divided by the same thing, root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So what can we conclude from here? What is the constant that is existing in all the three? Can I say 1 divided by root of this x2 minus x, this whole thing 1 divided by the denominator? Right? So can I say from here that cos alpha is proportional to x2 minus x1? Similarly, what is cos beta? Cos beta is proportional to y2 minus y1 and cos gamma is proportional to z2 minus z1. So cos alpha, cos beta and cos gamma being the direction cosines, they are proportional to values x2 minus x1, y2 minus y1 and z2 minus z1. What are those three values called as? So if cos alpha, cos beta and cos gamma are given by these expressions, then the corresponding direction ratios are what? So these three values are called as the direction ratios of the given line. So when you want to find the direction cosine, what will you do? You will take the difference in the x coordinate and divide it with the distance between those 2 points. Whereas if you want only the direction ratios, what will you do? You will just take the difference between the corresponding coordinates. So x2 minus x1 is equal to a, y2 minus y1 is equal to b, z2 minus z1 is equal to c. So what we did here is addition to finding the direction cosines of a line passing through 2 given points, we also found the direction ratios.
Sir,
Tell me that.
sir, can you tell like when should we use directional cosine and
I tell you,
directional
that is. See, first exercise, there is no problem, don't worry. Second and third only it will talk to you. I'll tell you at that point. Now, if I tell you, you'll get confused.
Okay.
Okay. So, try out the example problems. So, first, in page,
Sir,
tell me. Tell me. Yeah, tell me. Subrajit, tell me that.
sir, so x2 minus x1 is the directional ratio, right?
Is a direction ratio.
Okay, sir. Got it, sir.
Yeah. So, if you solve the problem, you'll understand it. Listen. So, in example 1, right? In example 1, if you see, what is the first part they're asking? So, if a line makes an angle 90 degree, 60 degree, and 30 degree with respect to the positive direction of x, y, and z axis. So, what do you mean by positive direction?
Theta is measured in anti-clockwise.
Huh?
Theta is measured in anti-clockwise.
Correct. So when you say something, when you say the angles are positive, angles are measured in the anti-clockwise. Okay. So alpha, beta, and gamma are 90 degrees, 60 degrees, and 30 degrees respectively. So what are they asking you? Find the direction cosines. Cos alpha, cos beta, and cos gamma. And remember, when you're writing the direction cosines or direction ratios, never put them within a bracket. Listen to this carefully. Cos alpha cos beta, cos gamma. Don't write it like this because if you put them within a bracket, it will become like a point. They are not points. They are just numbers which are associated with the letter. Okay. So cos alpha, cos beta, cos gamma will be cos 90, cos 60, and cos 30. Cos 90 is 0, cos 60 is 1 by 2, and cos 30 is going to be 50 by 2. So these are the direction cosines. Just for our satisfaction, do one thing is do L square plus M square plus N square and see what I get.
One.
You get a 1 because cos square 60 is sin square 30. Sin square 30 plus cos square 30 is 1. This is how it works. Guys, are you able to understand? Those who are online, are you able to understand? This
Yes, sir.
exercise is very important. Okay. Focus on. Equation of lines is try the exponent. Shall I proceed? So look at example number 2. So when you look at example number 2, if a line has direction ratios, what are they given? A comma B comma C is equal to 2 comma minus 1 comma minus 2. So if the direction ratios are given and you are expected to calculate the direction cosine, what are we supposed to do? L will be equal to plus or minus A divided by root of A square plus B square plus C square. F will be equal to plus or minus B divided by root of A square plus B square plus C square, and N will be equal to plus or minus C divided by root of A square plus B square plus C square. So L will be equal to plus or minus A divided by root of what are they? So root of 4 plus 4 plus 1, so root 9. Will be plus or minus 2 divided by 3. So M will be minus or plus minus 1 divided by, sorry, minus or plus 1 divided by 3. N will be minus or plus 2 divided by 3. So I hope you understood what the meaning of plus or minus and minus or plus. So when you take L to be positive, the corresponding value of M you are supposed to make it negative, and N also should make it negative because that is the upper sign. For lower, when you consider this to be negative, M will be positive and N will be positive. Okay, then. Proceed. So example 3. Okay. Find the direction cosines of the ray passing through the 2 points. P is minus 2, 4, and minus 1. Q is 1, 2, and 3. So what are they asking? They're asking the direction cosines. So when you read the direction cosines, it is the difference between the coordinates divided by the distance between them. So how to remember this? Remember it like this. Cos is what? It is a ratio. Whereas when you write the direction ratio, what will you do? You will not take any ratio, just take the difference. Okay. So what are going to be the DCs? DCs of 3 will be x2 minus x1 divided by square root of. Can you tell me what is PQ? Root of 3 square plus 2 square plus 8 square. So that will be root of 9 plus 4 plus 64. 77. So it will be 3 divided by root 77, comma, minus 2 divided by root 77, comma, 8 divided by root 77. So when you're applying the formula, be very careful. Don't write x1 minus x2. Always write it as x2 minus x2. Distance one. Root of x2 minus x1 the whole square. Apply that. 1 minus of minus 2, 3. So 3 square. 2 minus 4, minus 2 square. 3 minus of minus 5, 8.
Sir,
Then,
sir, why is that in the previous example they've given only one of the combination of the answer in example 2?
example 3, I didn't get your question.
No, sir. In example 2, they've given the answer is given is only one of the
They've
combination of
taken
what
like
you
it's
wrote.
fine. You can still write it as plus or minus. They considered those direction cosines are with respect to the angles made in the positive direction. You can still write it as plus or minus. No harm in it.
Okay, sir.
Because in that question they have not, if you see the difference between the first and second, in first they have clearly mentioned positive direction. Second, they didn't mention anything. That is why it is safer bet to write it as plus or minus. Okay. Example 4. Find the direction cosines of x, y, and z axis. So what is the angle made by a line with the x-axis itself? See, the angle made by that line with y-axis and z-axis will be 90 and 90. So, how many lines can you consider? You can either consider a line which is oriented along x direction, or you can consider a line which is confined to y direction, or you can consider like confined to z direction. So there will be 3 different combinations of direction cosines possible. So if you take for x-axis what is the direction cosine, then it is going to be cos 0, cos 90, cos 90. Similarly, if you take the DC, so I'll be writing DC on here. Okay, I'm not writing the direction. So DC for y-axis will be cos 90, cos 0, and cos 90. And DC for z-axis will be cos 90, cos 90, cos 0. So what will be the numbers? 100 or 010 or 00. Okay. So instead of saying or, I would rather say and, because if you see the question they have asked for x-axis, y-axis, and z-axis. It will say or. So for x-axis the direction cosines are 100. For y-axis the direction cosines are 010, and for z-axis the direction cosines are 001. Okay. So the next one is an important one. Listen to this carefully. I'll give you a task. Read the question. Example 5, read it. I want everybody to concentrate. Example 5, they are speaking about collinearity. So they told, I'll give you 3 points. What are they? 2, 3, minus 4. That's what I'll B1, 1, minus 2, 3, and C is 3, 8, minus 7. So our job is to prove that these 3 points are collinear. Right. So when 3 points are given, right, if they are collinear, all the points are going to lie on the same line. So for that line, for any given line which is passing through 2 points, right? What are the 2 important parameters we can define? One is direction, cosine. The second is direction. Okay. Now I want you to do 2 things. Break the page into 2. One side, find the direction cosines. One side, find the direction ratios and tell me the answer. So break the page into two parts. Left hand side, I want the values of DCs. On the right hand side, I want the values of DRs. That is the direction ratios. Do it fast. So first find the distance between AB, BC, and CA. Is it over? We complete we define the direction cosines and ratios. So if you observe that direction cosines are exactly the direction cosines are exactly the same number, whereas direction ratios are proportional. So direction cosines will exactly be the same number, whereas direction ratios will be in proportion. Meaning of it is, whenever you want to prove the collinearity, listen. Whenever you want to prove that the points are collinear, what you need to do is find the direction ratios. Okay, you need not find the direction cosines every time, but if you find the direction ratio and it comes out to be in proportion, then you can say that the points are collinear or they are parallel as well. Whereas if the direction cosines are the same, that also we conclude that the points are collinear. So what is that you can conclude from here? Either of the conditions is more than sufficient for you to do the collinearity. Okay. So next time when you're solving the same set of problem, you need not find the direction cosine at all. Find the direction ratios. If the values of the direction ratios for AB and BC are in proportion, means if it is in the ratio 1:2 or 1:3, something like that, you can conclude that they are collinear. Okay, this is another important point that you need to have in your mind. Okay, so these are the set of problems that are based on the direction cosines and the ratios. So I give you 10 minutes time. Solve 11.1. You can finish it in 10 minutes. That's maximum. Okay, finish it off. Do it fast. All the problems were easier. Those are online. Those who are online. Did you complete the first exercise?
So last
Yes,
question,
sir.
sir.
Yes, sir.
Is it easy?
Sir,
Yes, sir.
Yes. So the tough part will start from tomorrow. Be prepared, okay? So I'll tell you when to use the DCs and the DRs so that we'll discuss in tomorrow's class. Well, I'll prepone it, Ram. Okay. So we'll wind up this.